Hello, my little mathematicians. Today, we're going to review adding and subtracting fractions. Um, just since it's a quick warm-up, I want us to just try together the first column, A, E, I, M, P, and Q. Go ahead and try those on a separate piece of paper, and then once you think you have them figured out, unpause the video and come back and check yourself. So for the first one, since I don't have that much space, I'm just going to do it on a separate sheet of paper. I want us to try A, and it's 1/4 plus 3/5. Whether you're adding or subtracting fractions, you always want to get a common denominator. So I think to myself, what can 4 and 5 both become? Well, 4 can't become 5. 5 times 2 is 10. 4 can't become 10. 5 times 3 is 15. 4 can't become 15. 5 times 4 is 20. 4 can become 20. They both can become 20. So that's my LCM, or common denominator. Then you want to rewrite equivalent fractions. So 4 times what is 20? 5. So do the same thing on top. 1 times 5 is 5. Now you have an equivalent fraction to 1/4. You have 5/20ths. And the reason I'm doing this is so that then I'll create another equivalent fraction here, but with common denominators, because you can't add or subtract until you have a common denominator. So let's continue. 5 times what is 20? 4. So 3 times 4 is 12. Now you have 5 plus 12. Add the numerators and keep that denominator the same. Can you reduce it? No. Is it improper? No. So then you're done. For the next one, I want us to try E, I said. Okay, E is 3/8 and 9/16. Think to yourself, what can 8 and 16 both become? Look at the bigger number, 16. Can 8 become 16? It sure can. So that's my common denominator. 8 times what is 16? 2. So 3 times 2 is 6. 16 times what is 16? 1. So same thing on top. 9 times 1 is 9. Now that you have equivalent fractions to your originals, but with common denominators, keep the denominator the same. Add your two numerators. 6 and 9 make 15. Can you reduce it? No. Is it improper? No. So you're done. The next one I wanted us to try was I. I says 1/2 plus 2/7. Look at your two denominators. What can 2 and 7 both become? Can 2 become 7? No. So 7 times 2 is 14. Can 2 become 14? Yes, they both can. So then we're going to write equivalent fractions. So think to yourself, 2 times what is 14? 7. So 1 times 7 is 7. 7 times what is 14? 2. So same thing on top. 2 times 2 is 4. Now that you have equivalent fractions, the originals, but with common denominators, keep the denominators the same. Add your numerators. 7 plus 4 is 11. You can't reduce it. It's not improper, so you're done. My next one I asked us to try is M, which says 7/8 minus 1/4, and then add 1/2 to that answer. So first off, let's focus on this 7/8 minus 1/4. Okay. So rewrite them vertically. What's your common denominator of 8 and 4? 8. They both can become 8. 4 times what is 8? 2. So same thing on top. 1 times 2 is 2. 8 times what is 8? 1. So same thing on top. 7 times 1 is 7. Now it's the same thing as when you were adding. I keep the denominator the same, but the only thing that's different is instead of adding those numerators, I'm going to subtract them. So 7 minus 2 is 5. Can I reduce it? No. Is it improper? No. So I technically would be done, but not quite yet, because that's just this part is 5/8. But now you want to add 5/8 to 1/2, right? Because we did this part. Now you're going to combine that answer, 5/8, with the 1/2. So 2 and 8 can both become what? 8. So then 2 times what is 8? 4. Same thing on top. 1 times 4 is 4. 8 times what is 8? 1. So 5 times 1 is 5. Now these I'm adding, so keep the denominator the same and then combine your numerators. 5 plus 4 is 9. Can I reduce it? No. But are they proper? No, actually. So it's improper, which means I need to change it to a mixed number by taking the top, dividing it by the bottom. So 8 goes into 9 how many times? Once. 1 times 8 is 8. When you subtract that, 9 minus 8 is 1. So you put your denominator or your remainder over what you were dividing by. So 9/8 is the same thing as 1 1/8. The next one I want us to try is P. It was that word problem. So for problem P, let's take a look at it. It says a big burger has 1/4 pound of meat. A super burger has 1/3 pound of meat. How much more meat is used for the super burger? So the super burger is more. And when it says how much more, that's your hint that you're going to subtract. You're going to find the difference between them. So it's the bigger thing minus a smaller thing. It says how much more does Super Burger have? So I know that Super Burger has the larger amount. And Super Burger has 1/3. So I'm going to do 1/3 minus 1/4. Okay, so this was P. Let's go ahead and label that. And we said it's 1/3 minus 1/4. Well, what can 3 and 4 both become? They both can become 12. 4 times what is 12? 3. So 1 times 3 is 3. 3 times what is 12? 4. So 1 times 4 is 4. Now keep the denominator the same and subtract your numerators because we're subtracting this time. 4 minus 3 is 1. Can you reduce it? No. Is it improper? Nope, it's proper, so we're good. Okay, and the final one I asked us to do, if I take a look, is Q. Q says, Kent walked 3/4 of a mile on Monday. On Tuesday, he walked 1/8 of a mile less than on Monday. How far did he walk altogether? How far did he walk altogether means how far did he walk Monday and Tuesday? But I don't actually know how much he walked on Tuesday. I know he walked 3/4 of a mile on Monday, but on Tuesday it says he walked 1/8 of a mile less than on Monday. So first, I need to figure out how far he walked on Tuesday. So to figure out, okay, this is problem Q, Tuesday. Okay, on Tuesday, he walked 1/8 of a mile less than Monday. So I'm going to take Monday and subtract 1/8 of a mile. And that will give me how far he walked on Tuesday. So what's your common denominator of 4 and 8? 8. 8 times what is 8? 1. So 1 times 1 is 1. 4 times what is 8? 2. So 3 times 2 is 6. Now keep your denominator the same and subtract your numerator. 6 minus 1 is 5. So that means on Tuesday, he walked 5/8 of a mile. But I want to know how far he walked altogether. That's just Tuesday. So I need to know how far did he walk Monday plus Tuesday, right? To get all together. Well, on Monday, they told us Kent walked 5/8 of a mile. And then on Tuesday, oops, I just messed up. Sorry. On Monday, they actually told us it was 3/4 of a mile. And then on Tuesday, we just figured that out. Tuesday is what we figured out was 5/8 of a mile. Okay, so to find all together, I'm going to add Monday plus Tuesday together. And this is why you should always do math in pencil. Okay, so right here, 3/4 for Monday and 5/8 for Tuesday. What can 4 and 8 both become? They both can become 8. So 4 times what is 8? 2. 3 times 2 is 6. 8 times what is 8? 1. So 5 times 1 is 5. Now keep your denominator the same. 6 and 5 make 11. Can you reduce it? No. But is it proper? No, it's not proper. It's improper. So I need to take the top and divide it by the bottom. 8 goes into 11 once. 1 times 8 is 8. When I subtract that, I get 3. Put your remainder over what you divided by, which means he walked 1 3/8 of a mile all together on Monday and Tuesday if I were to add those both together. Now, if you got all those right, congratulations. If you missed any of those and you maybe want to try a few more, here are the answers, okay, to the rest. So if you want to go ahead and try a few more similar to the ones that you missed, pause the video, try them, and then unpause it and check. There are your answers. Okay, and then if you want to see the specific work for those answers of how we got them, again, you can pause it on this screen and you can check to see if you worked it out where you made your mistake. Okay, so again, if you got them all right, congratulations, you understand. If you missed a few, then feel free to try one similar to the ones that you missed, and then check yourself right here by pausing the video and checking your work with these. Congratulations, you're hopefully a little bit better at adding and subtracting fractions.